Hello everyone, I'm Jay Joshi and welcome to the 31st episode of Learning Java. Today, we'll be learning about recursion. So, first of all, what is recursion? So, as you all know what for loops are, right? So, a for loop is basically a loop in which we keep executing a part of a code again and again and again until a particular condition becomes false. So, that's what a for loop is. And even do while and while loop is basically when we keep on repeating a particular part of a code. Now, some of these loops can become very long and very complex if we have to perform some very kind of a complex operation. So how can we make it simpler? So to make it simpler, we have something called recursion, a recursive technique. So as you can see, I have a code written over here. I have a class practice sticker. I have a main and I have a static function called rig. Now you might see that in main that I'm calling the function. So that's perfectly fine. I'm calling the function in main. But you might also notice that I'm calling the function rig inside itself. And there's only one function. So I'm calling this function rig inside itself. This is what recursion is. So recursion is basically calling a function inside itself. So I have this function over here rig with an integer parameter, and I'm calling this function inside the function itself with an integer parameter. So this is what is recursion, calling a function inside itself. And this you can see how it's leading to the formation of a loop. So when this function is called, it performs all this operation and then it's called again. So it keeps on going in a loop, in a loop, in a loop until what we call a recursion. So the base case in recursion. So this over here, this if condition is our base case. So a recursion is basically calling a function. It's like a function calling itself, and it goes on calling itself until the base case is true. So until the base case is false. So when the base case becomes true, the recursive function stops, and then it just goes back to the main. And this is a very useful technique. It's not that difficult. It's easy to understand to get the output of programs, but it's a bit difficult and tricky to implement in your own programs. So you'll have to think based on this, and a lot of practice will make you actually want to implement this in your programs. So this is a very important topic if you want to write very big codes in a very small and simple way. So I have this code over here, this public static void rig. It has an integer parameter and it doesn't return anything. You can see I have a return statement over here, but there's no like variable after the return. That's because it returns void. So I can just have a return statement. So when this return is executed, it just transfers the control back to the main. Now I'll be showing you the output of this program code, and then I'll be explaining the advantages and disadvantages of recursion and how we can use it in our program codes. So I have this code copied on a Word document, and now let's go through its data. So I'll be showing a very simple method of doing a dry run for a recursive technique. So I have the function rig over here. So I'm writing rig. Okay, this is the name of the function, and the parameter right now when the function gets called. So you can see that we are calling the function rig in main with the value 456. So the integer n is 456. This is a parameter. So when this function is called, first of all, it checks if n is equal to 0, which it's not. So the first condition is false, so it doesn't do the return part. Then it directly comes to the SOP. So then in this function, it prints SOP. This is very basic and standard stuff. So it prints n mod 10. So what is n mod 10 over? 456 mod 10 is 6. So when you divide 456 by 10, the remainder you get is 6. So it prints 6 over here. Fine. And now it goes to this statement, rig n by 10. So then it calls this rig function again inside this rig, which has a parameter 456, with an n value of n by 10. What is n by 10? 456 by 10, which is 45. So this will be 45. Now inside this rig 456 with the parameter 456, it's calling the rig 45 function. So now we put an arrow over here. And now again, so this rig 45 function is called. So we come back to the first statement over here. So the parameter is 45. So is 45 is equal to 0? No, it's not. So it goes to the SOP statement. So it prints SOP and then it prints n mod 10. So 45 mod 10, which is 5. and then again it calls the function rig again, so rig, and then it does by 10, so n by 10, so n right now is 45, 45 by 10 is 4. Now again, this is again, now the function rig is called again. So let me just go to the next page. So when this, now this rig function is called, this rig 4, again, it goes back to the first statement. It checks if 4 is equal to 0, which it's not. Then it does system.out.println n mod 10. So what is 4 mod 10? It's 0. So it prints SOP. So it prints 0, right? And then it goes back, and then so then it calls the function again rig n by 10. So 4 by 10 is 0, so then it calls the function rig with the parameter with no parameter basically, so it's 0 because 4 by 10 is 0. Now when this rig function is called again, then it checks if 0 is equal to 0, which it's true. So then it just returns, and then the function stops over here. Now in recursion, so now what we have to do is, so basically in recursion, it's based a lot on memory. So you will understand recursion a lot better when you learn about memory and stack. These are two very important terms in Java. So after the final loop, so this function is now stopped, right? But all these functions, this rig4, rig45, rig456, 456, these functions were never actually terminated. So while they were being called, another function was called. So Java went to the other function. But the execution of these functions is still remaining. So after the final line, so after the final function stops, the program backtracks. So then it goes back to check if anything's pending. In this case, so when will it be pending? Let's say there was an SOP statement over here. So let's say there was an SOP statement. Let's say SOP, there was SOP H. So it's printing H over here after this rig. So let's say when this 456 function was called, and then inside this 456, we have rig45, there would be an SOP statement still pending over here. So SOP H, this statement would have been pending. In this rig45, when rig4 was called, again, SOP H would have been pending because this would have never been called. So we put it on the side, right? Since this is pending. Then again, when rig0 is called, again, so when I call rig0, it just returns. So the rest of it is in pending because it just goes back. So after this has been ended, the program backtracks to check if there's anything pending. So then it first backtracks. So let me do this with a red pen. It first backtracks to this SOP. It prints this H. Then it prints this H. And then, yeah, so that's it. There were no pending H's again. So like that, it just backtracks. So this is not the best example of backtracking in recursion. I'll be showing you a next example of factorial in that backtracking is a bit more clear. So what I'm trying to say is this is how recursion basically works, and this is how you can do the output. So let me just write the output over here. Let me change the color to let's say blue. So first 6 was printed, so it's system.print. Okay, 6 is printed. Then 5 was printed, so we print 5, and then 0 was printed. So 650. So this would have been output, and if this H also would have been there, and then we would have double H, because at the end it just backtracks. So this would have been output with the H, and without the H, 650 would have been the output. So this is what basically recursion looks like. Now let me show you another example. Now this might seem a bit random. This example, it doesn't have like much of a use, but now I'll be showing you a better example for recursion. So here we have another example of recursion. So this, as I said, will be an example of a factorial thing. So we have to calculate the factorial of a particular number. Factorial is basically the multiplication of all the numbers before a particular number. So this code over here, so this function, you can see this fact function calculates the factorial of a particular number which the user enters. So this is the main code. It's pretty basic. You ask the user to enter a number, he enters the number which is stored in n, and then we print the factorial, fact n. And you can see inside this fact function, we are calling the function fact once again. And this is our base case if n is equal to 1. Now, this program is a perfect example of backtracking. So you'll see how Java backtracks in this. So I've already copied this code into this so we can see the output. So let's assume n to be 5. Let's assume that the user enters the value of n to be 5. So now let's have a look at the trial. So first, this fact is called a fact of 5, right? So it has to calculate the factorial of 5. So first it checks if phi is equal to 1, which it's not. Then it returns, so since this false, then it just returns phi into fact of n minus 1. So n is phi, so it'll be return fact of 4. Phi minus 1 is 4. So phi into 4, a fact of 4. Now, this is another function, this fact of 4. So it's going to call this function again, fact of 4. It checks if 4 is equal to 1, which it's not. So it returns 4, so n into fact of n minus 1. Fact of n minus 1, which is 3. Then it checks if 3 is equal to 1, which it's not. So it does 3 into fact of 2. So like this is how recursion is basically taking place. And you can see how this will backtrack later on. Then again 2. So 2 into fact of 1, right? And now when this factorial of 1 function is called fact of 1, it checks if 1 is equal to 1, and then it returns the value 1. So over here the value 1 is returned, and thus our recursion stops. So this is where our recursion stops, and now backtracking starts. So fact 1, this entire function now has the value of 1. So it does 2 into 1, which is 2. So this fact 2 function now has the value 2. So it does 3 into 2, which is 6. So fact 3 has the value 6. Then it does 6 into 4, which is 24. And then fact 4 assumes the value 24. Then 24 into 5 is 120. So then fact 5 has the value 120, which is the value it actually returns in the main. Over here you can see. And then it prints out the factorial of 5, which is nothing but 120. So you can see how we calculated the factorial of a number, and at the end it just started backtracking. So like this, it kept on backtracking to those required values, and those functions got those particular values, and then it multiplied based on that. So you can see how we calculated, like, so if you just try to do this factorial function in your normal for loop, although you can do it in a quite a simple way, but in recursion as well, you can do it in just 3 lines of code. So it's a very simple and effective technique, and it's a very simple and easy technique to understand, but it's a bit difficult to implement in your codes. Now I'll be telling you some advantages and disadvantages of recursion. So as you can see already, the advantages are it makes complex code smaller, etc. I'll give you an example of which code you can try. So there's this complex code to do without recursion to find out the anagrams of a number. So anagram is basically, let's have a number, a word TOP, and I want to find all the possible combinations of this number. So all the possible combinations will be POT, TPO, and so on. So it'll be OPT. So I think there'll be like 6 combinations possible. There are many more. So you have to write a program code to print out all the anagrams of a particular word. So try this program code on your own. It's going to be very big if you use a for loop, but it's going to be hardly like 6 to 7 lines if you use a recursion function. So if you use the recursive technique, it's going to be very small. So like that, recursion helps to make the code more compact and simpler. But a disadvantage of recursion is that not everyone understands it. It's a bit of a difficult technique to implement, and it occupies a lot of space in the memory. So you can see how when this function is being called again and again, all these previous functions are being saved in the memory, in the stack. So this is why recursion occupies more space, and recursion can also be very time consuming in some cases, but can also be very time saving in some cases. So again, recursion, all in all, it's a very useful technique. It's just that it occupies more memory and stack. So that's it for the recursion technique. Again, I'll be making another video of more examples with recursion, especially for backtracking, so that you understand the concept even better. So again, as I always say, try to use recursion in your codes, get the hang of it, do output questions, make a code in your own, and try to predict the output. It's the best way of learning. So that's it for recursions, everyone. Thanks for watching. And if you have any queries, doubts, or suggestions, you can mail me. My email will be in the description down below. And thanks again for watching.